So, continuing from the previous lecture, we'll be discussing the solar thermal power generation in this lecture. Concentrated solar power, or sometimes known as concentrating solar power, concentrated solar thermal system generates solar power by using mirrors or lenses to concentrate the large amount area of the sunlight into a receiver. Electricity is generated when the concentrated light is converted into heat and which drive the heat engine, or normally it is turbine that is connected to a power electric power generator or a power or thermochemical reaction. CSP has a global total installed capacity of around 5,500 megawatt in 2008, uh, and that was actually increased from 354 megawatt, which was in 2005. Spain, which is actually leading in the concentrated solar power, have got like 2,300 megawatt, even despite the fact that they have not installed any of the CSP in 2000 since 2013. United States have got 1,740 megawatts, while now the concentration is now towards the Middle East and somewhere in India and China as well. They are actually interested in the CSP systems. Uh, the global market normally about the CSP global market, it is actually dominated by the solar power trough or the parabolic trough, we call it, which is 90% of the CSP power plant. It's followed by the center power tower of CSP. Um, but that's because that the center power tower of that CSP, it actually can produce a temperature of around 565 degrees centigrade, comparable to the trough, which has got the maximum temperature of 400 degrees centigrade. Uh, Among the large CSP project are ANPA power, solar power facility, which has got 392 megawatt in the United States, while in second one is actually in Morocco somewhere, which has got the combined trough and solar technology, which actually have got the total capacity of 510 megawatt. Um, Obviously, when we are talking about CSP, we normally compare it with the photovoltaic, and it is because that, like in a recent year, the photovoltaic or PV modules, they have been actually extensively used, and there have been so much of the investment going on in the PV technology that the price of the PV is going down. Having said that, uh, PV have got one of the inbuilt problem, which mean like PV does not work in when there is no light. But CSP have got more, can actually store the energy, and obviously it can be more competitive with dispatchable generator and baseload plant, which mean like even the some of the projects which actually are running in the world, that CSP is providing the power throughout the days, which mean like a 24 hour. So that is what actually it CSP is as compared to the photovoltaic is much a little bit better. But owing the technology uh, complexity and the price of the technology, CSP is yet to actually, I would say, like make any challenge to the PV modules. But let's talk about the CSP anyway. A flat panel connector, normally, if we have talked in a previous lecture, even we if we have got a concentration of 850 irradiation of, sorry, 850 watt per square meter, the temperature which the flat panel collector would actually reach would be only 170-degree Fahrenheit, and obviously that's not a temperature in which we can actually produce a sufficient amount of steam, and obviously from that steam we can actually produce the electricity. So there are two concentrating approaches we use. One is actually through array of many mirrors that will focus sunlight on a single point or on a boiler, and which actually would produce the steam. And the second method is actually we have got a set of dishes or trough to focus light on a pipe or on a single line, and that would produce the heated water or heated steam for a boiler. So that's what we call it as a parabolic trough. So parabolic trough, if you can look at this figure, we have got a number of trough actually. Trough is actually parabolic somewhere like this. So we have got a number of linear parabolic reflector or trough, which is actually reflecting the sun radiation on a single line, and that line have got the tubes in it, and that in that tube or receiver, uh, we have got the working fluid in it. So the reflector follow the sun during the daylight hour by tracking along the axis, and the working fluid, which might be, for example, molten salt or might be even sometime water as well, is heated up to around like 100 150 to 100, 350 degrees centigrade, and the maximum of 400 degrees centigrade, as we have already discussed. And it flows through the receiver, and it is used as a heat source for a power generation system. Trough system are the most developed CSP technology. As I said a little bit earlier, that 90% of the CSPs are the solar trough. Um, the mirror, or normally, that's what we have already said, concentrate the sunlight and focus it on a network of stationary steel pipe, also suspended from the grease of the structure. Water is carried throughout the length of the pipe, which is boiled to generate steam when intense solar radiation is applied. So what we have got over here, like let's suppose we have got water going inside in this pipe, and once it is actually going through, so it will be actually gradually heated. When it passes to another trough, it will be heated a little more, and so on. When we have got so many passes actually, so the water will eventually boil and sometimes superheated as well. um, as of 2014, a large solar thermal power station using parabolic trough technology include the 350 megawatt that SEGS in California, we already discussed, and 280 megawatt in Spain, and 250 again in Spain, in Spanish, and so on. So what actually we have already discussed, like Spain are actually leading in the solar trough technology. So we have got the other power plant are normally in Spain as well. The other power plant, concentrated solar power plants, which is actually around like apart from the solar trough, is the halostate power plant. What is actually halostate? Halostates is are like a number of small mirrors which are placed in strategic location, and all of them, when sunlight actually incident on these mirror, they are actually focusing the sunlight on a common focal point. And in that common focal point, we might place a boiler, and which actually might have a water in it or molten salt in it. And when that water or molten salt is heated, that heat is actually utilized to produce steam, and obviously to run a steam generator. So the solar powered tower consists of array of dual axis tracking reflector. We call it as a halostate. Halostate normally mirror, which is actually dual axis tracker, that concentrates sunlight on a central receiver or the top of the tower. The receiver contain heat transfer fluid, and might be what we call it as a water, or might be the molten salt. Optically, solar power tower is same as the circular Fresnel reflector. The working fluid is the receiver is heated up to 500 to 1000 degree Fahrenheit, and then used to heat the source of the power generator, and obviously to to energy storage system. What is actually the advantages of the or what is actually the main feature of the solid state power plants? So temperature can go up to 5000 degree Fahrenheit. The parabolic reflector must be steered to follow the sun. Normally, it is two axis steering, so that means like it will be following the sun. Rather than actually steering the whole power plants, normally these mirror are steered, so that means like it will be actually only to concentrate the light on a single focal point. Temperature goes like the fourth law of the concentrated factor. You can actually recall the Blackwater radiation law, which actually Salamute used about for something. Um, the Planta solar power in the Spain is the first commercial utility solar power plant in the world. Then we have got 370 megawatt power plant or 354 megawatt power plant, or the Basta, which is actually near Basta. Solar facility is the largest CSP facility in the world, and that use three power tower, which is actually somewhere shown over here, and which is also over here. So normally the Basta Tower, which is at the solar power facility in United States, they have got somewhere around, like, if you can just check over here, they have got somewhere around like 1900 solar reflectors, or what we call it halostate, or the mirrors. So each of mirror is actually 20 feet by 20 feet reflector. So you can imagine we have got 1900 20 into 20 feet reflectors. So concentration factor can go up to 1000, but the peak power, which actually the Avampa power plant is giving us, or the Basta power is giving us, is 10 megawatts peak power, and even the average power is 5 megawatt. Which mean, like, if you are talking about the average power, that mean also mean like the when the power is sorry, when the sun is gone and when we have got only the storage available. So this is what actually the schematic diagram of the Basta Tower, or the working principle, in which we have got the halostates, uh, 1900 halostate, which is concentrated on a tower, where the steam generator is installed. When the molten salt is actually circulating into the another heat exchanger, or might be directly water circulating over here, which actually run the turbine, and turbine is connected to the generator and obviously to the electric system. Um, the next power plant, or the very simple power plant, or the solar energy utilization power plant, is the solar pond. Normally, solar pond is the saltwater pond, which actually absorb the a large salt water pond, which actually absorb the solar thermal energy. Normally, what we have got in a normal saline pond, or what we call it, that pond which have got the salt in it. So we have got a naturally vertical salinity gradient. For example, the salt would be actually less at the top, and when we go below the pond, the concentration of the salt would be increasing. So the layer of salt solution increase in concentration, therefore the density with the depth. Below the certain depth, the solution has uniform high salt concentration. So when the sun ray actually pass over here, normal pond, if I'm saying like without the salt one, if you can imagine. So when the in a normal pond, when the sun rays strike, actually, the heat is actually flowing into the water, and when it actually reached the when the water at the bottom of the pool is heated, it is because less dense than the cooler water above it. So that means, like, when the sun is reaching over here at the shallow pool, or if I would say like at the bottom, the heat started, the water heating it started actually. So normally the water would get heated at the bottom, while at the top of this the water would be less heated. So normally the water is heated at the bottom, and when it is heated, the heat is transferred to the up over there. But in normally high saline water, the heat is not actually transferred up there, but the salt is added to the until the lower layer of the water become completely saturated. So in high salinity water, at the bottom of the pond does not mix readily with the low salinity water above it. So that means, like, the heat is normally not transfer from the bottom to the top. So when the bottom layer is heated, convection occurs separately in the bottom and top layer, with only mild mixing between the two. This greatly reduce the heat losses and allow the high salinity water, which is at the bottom, to get up to 90 degrees centigrade, while maintaining 30 degrees centigrade at the low salinity water, which is above it. This hot salinity water, which is at the bottom, can be pumped away to use in electricity. Or in other words, this 90-degree water can be used to transfer the heat to another system or another working fluid, or what we call it as water, and obviously to alternatively to use the electricity generation through a turbine or some electric or some thermal resources. So what are the advantages and disadvantages of this solar pond? The approach is particularly attractive for a rural area or developing country. Very large area collector can be set up for just a cost of a clay or plastic pond liner. That means like we can just have a huge pond, and a pond can be utilized as a heat sources. The accumulated salt crystal have to be removed, so obviously to can be able to byproduct and maintenance expenses. So that normally when we have got the salt in the water and we have got a pool, so normally the salt itself or the evaporation itself would make the concentration of the salt more, so you have to remove some of the salt. No need for the separate collector. The extremely large thermal mass, that's what we can imagine. When we have got a large thermal mass, that means like power can be generated night and day. So that would less power losses, heat losses, and obviously we can extract or we can generate the power throughout the night and day. But relatively low temperature operation mean like solar energy conversion is typically less than 2%. So you can imagine like the efficiency can up to drop up to 2%. But as I've said, like it is free. So obviously you can actually imagine like the solar pond have got some a little bit of the electricity as well. Due to evaporation, non-saline water is constantly required to maintain the salinity gradient. That's why I say like when evaporation is there, so it would be actually the concentration would be different, and obviously you have to maintain that concentration. Um, the largest operating solar pond for electricity generation using the pond is actually in Bait Allah, somewhere around like Beth Haravi in Israel. That is actually installed in 1988 something. It has got a large area and have got like a maximum power of 5 megawatt. The second largest is in Gujarat, Bhuj, Gujarat in India. Then we have got another technology for generating electricity from the solar, and that is solar photovoltaic. So how the solar photovoltaic works? So in a normal silicon cell, if we can say, we have got a valence band and we have got a conduction band. So when the photon is incident on the valence band, so the electron would be getting excited, and when it is getting excited, actually it will be jumping from the valence band to the conduction band and actually leaving a electron pair, sorry, hole in the valence band. So the more the photon energy is incident on the valence band, the more the electron will jump from the valence band to the conduction band, and the more the hole and electron pair will be created. Uh, this produce the jumping of the electron from the valence band to the conduction band produces the electric current, and that can be utilized to light up the lamps, or if I would say like to produce the electricity. The solar cell is somewhat like a battery, but definitely different in working. A battery put out the constant voltage up to some maximum current, while the silicon photovoltaic put out the current that is proportional to the intensity of the light that is shining on the solar cell. And the maximum voltage that can silicon can give would be zero point 0.6 voltage. Obviously, this voltage, 0.6 voltage, is of no use. So, in many cases, or in all of the cases, there is actually we call it as the single cell would sorry the we have got the stacking of the cell in series to get the useful power. Typically, there are 36 cell, and that is about 21 volt. but when we put load on it, what we call it as a charge load on it, so that drop from 21 volt to 16 volt, and that is actually sufficient enough voltage to charge the 12-volt batteries. The maximum efficiency of silicon is around like 23%, with 15%, sorry, 54% losses as a heat waste. Efficiency greater than 40% is achieved, and in many cases it is achieved in a what we call it as a more complex solar cell, or what we call it as organic solar cells. So 40, more than 40% is achieved, but silicon being abundantly available and obviously the cheap material, so that's why the maximum solar cells are made of silicon, and the efficiency of the silicon is still around like 23%, but commercial silicon efficiency is around somewhere around like 12 to 15%. um, let's have an example. So we have got a Leamington solar farm. So in a Leamington solar farm, we have got around like 7,000 solar panels installed, which give us a power of 180 kilowatt average, which can light up 250 homes. 10% of Leamington campus, that is actually lighted up by the Leamington farm. 300 carbon saving per year, and cost of them was actually $10 million, which we have got a level as cost of 20 year, and produce electricity at 32 cent per kilowatt hour. Having said that, can you also check the Kadazam solar power plant, Kadazam solar power plant, and that is actually installed in a Cholistan desert. The more details are also on the internet or Wikipedia. You can find much detail of the Kadazam solar park. There are around like still around like 390,000, roughly around 400,000 solar panel installed in a Kadazam solar park, which is giving around like 100 megawatt of electricity. It's a like the unit of electricity is around like 19 cent per kilowatt hour. But you can check it on a internet and many other website. Now, if I'm looking at the current power requirement of Pakistan, which is actually 25,000 megawatts. So if I'm looking at the 25,000 megawatts power plant, sorry, solar power generation. So the if I'm installing it somewhere in Balochistan, and I'm taking the average of power of Balochistan as 300 watt per square meter, uh, keeping in mind even like Balochistan have got 5.2 kilowatt, so much more than this one. So just looking at the 300 watt per square meter in Balochistan, and of 15%, which actually I said like around the silicon solar panel, so it come up as 45 watt per square meter. So doing your calculation, the area that would need it for 25,000 megawatt for the whole power Pakistan would be 500 square kilometer. So if we can install a solar power plant in 500 square kilometer, then we will be sufficient enough power for the whole Pakistan. I hope you understand this solar power or solar energy lecture. If you have got any question, you can post it in the Google Classroom. Thank you very much. Have a nice day.